NASA's sharpest camera on Mars looked into the largest canyon in the solar system and found a warning hidden in the rock. Mars was not simply wet or dry. It changed repeatedly, violently, and its giant scar preserves that history. Valles Marineris is not a single canyon. It is a system of linked chasms more than 4,000 kilometers long, up to 200 kilometers wide, and roughly 7 kilometers deep. If placed on Earth, it would stretch across the United States. It cuts along the flank of the Tharsis volcanic rise, near some of the largest volcanoes in the solar system. For years, people called it Mars's Grand Canyon. That comparison is useful for scale, but wrong for origin. Earth's Grand Canyon was primarily carved by a river. Valles Marineris began mainly as tectonic fractures. As the Tharsis region swelled billions of years ago, the crust was pulled apart. Faults opened, blocks dropped, and sections of the surface collapsed. Landslides, wind erosion, groundwater, volcanic activity, and perhaps flowing surface water then modified the damage. NASA's HiRise camera has been watching these walls from the Mars Reconnaissance Orbiter since 2006. Ideally, HiRise can resolve features about 25 to 30 centimeters across per pixel. It lets scientists examine boulders, dunes, layer boundaries, and fresh slope changes with unusual precision. And the closer HiRise looked, the less Valles Marineris resembled a dead crack. The walls expose immense stacks of layered deposits, in places kilometers thick. These layers are a chemical and geological archive. HiRise reveals their shapes and relationships, while spectrometers such as MRO's CRISM identify minerals within them. Sulfates, clays, and iron-bearing minerals show that water altered parts of this region long ago. But scientists still debate the exact environments that created every layer. Groundwater rising through rock, lakes that evaporated, volcanic ash, wind-blown dust, or combinations of all of them. That uncertainty is important. No image has proven that Valles Marineris held one giant ocean, and no camera image proves ancient life. The strongest conclusion is more precise. Water and rock interacted here repeatedly, under changing conditions, across a long period of Martian history. HiRise also revealed surfaces shaped by gravity on an astonishing scale. Enormous landslide deposits spill from canyon walls onto the floors, some traveling tens of kilometers. Their broad, lobate shapes can resemble flows of mud or liquid. But Mars does not need present-day water to make them. Dry rock and dust can move great distances under low gravity, especially when the material is weak or fragmented. HiRise lets scientists measure the scars, boulder fields, and debris paths that test those ideas. Then there are the dark streaks. In several Martian locations, including parts of Valles Marineris, narrow dark markings appeared to grow seasonally down steep slopes. They were called recurring slope lineae, and briefly became one of the strongest candidates for modern briny water. Later high-resolution observations and modeling shifted the leading explanation toward dry granular flows of dust and sand. Liquid water has not been confirmed in these streaks. That change is a reminder that Mars can imitate water with dry physics. One of the most exciting findings connected to the canyon came from another spacecraft, not HiRise. In 2021, the FREN neutron detector aboard the ExoMars Trace Gas Orbiter reported unusually high hydrogen signals in central Valles Marineris, consistent with water-rich material buried near the surface. It could represent water ice or hydrated minerals, but it has not been directly sampled. HiRise supplies crucial topographic context, yet a future lander or drill would be needed to confirm what is there. So what did HiRise discover over Mars's giant scar? Not one impossible object. Something better. Evidence that this canyon is a layered record of tectonic tearing, volcanic history, ancient water chemistry, massive collapse, and modern dust movement. It teaches us that Mars did not lose its habitability in a single event. It changed region by region, era by era. The next images may help choose landing sites where a rover could read those layers directly. Follow for more Mars discoveries, and tell me, if you could send one mission into Valles Marineris, would you search the ancient water-altered rocks or drill for the possible buried ice?